Okay, so number one just says let f equal this very messy function here, right? And it tells us that x is 12, y is 8, and z is 15 degrees, right? Calculate the exact value of f, right? So we literally plug everything in. Now, we do have to be careful, all right, when plugging in things into trigonometric functions into our calculator, all right, for two reasons. One, as soon as you hit the sign button, it's going to automatically open up a parentheses, all right? So the calculator would automatically open up a parentheses here. I could put 2 times 15, all right, but because that's the only thing that's meant to be part of the argument of sign, we need to be very careful to then close that parentheses before putting in the -1 and closing that parenthesis as well. All right, then we have that times 2 times the tangent. All right, again, as soon as you hit tangent, it'll open up a parentheses. 3 times 15, we need to know to close the parentheses there, then have that +1 and close the parentheses. All right, and that is all over x squared, so 12 squared minus y squared, which is 8 squared. All right, so now that we have that, we can go ahead and plug it into our calculator exactly as we see it. All right, so I'll do our fraction command here. I'll open up a parentheses, 4 times the sign. You really don't have to write it as 2 times 15, right? You just, okay, well, 2 times 15 is 30, right? That's perfectly sufficient. All right, -1, close that parentheses, open a new parentheses, 2 times the tangent. Again, 3 times 15 or 45, close that parentheses, +1, close that parentheses, and then all over 12 squared minus 8 squared. Of course, similarly, you could have just said 144 minus 64, right? Either way, totally fine. All right, we hit, and got some funky answer. Again, the other thing that we need to be careful about when we're dealing with trig functions, all right, is our mode. In IB, we will always be on degree mode. All right, there will never be a radian mode in here. So we put that in again. All right. Now, technically, the exact answer, you could write that and it would give it to you. All right. But if you want it as a decimal, right, just do math, the little arrow to DEC, right? So we get 0.0375.
Is that 380?
Yep. All right. You also, if you don't remember where the two decimal thing is, if you get 3 over 80 as a fraction, just do 3 divided by 80, like not using the fraction command, and it will give you that same decimal. Yes, always in degrees. Okay. So now give your answer to F correct to 2 significant figures. Remember, zeros out front don't count. So 3 is my first significant figure. All right, 7 is my second significant figure, so I'm rounding to this place here. Because the number after it is a 5 or higher, I will round that up to an 8. So this would be 0.038. Right, just to 2 decimal places. Of course, the 3 is my second place after my decimal, so I would round it to this place here. Again, the number after it is a 5 or higher, so I round that 3 up to a 4, and that just becomes 0.04. All right, Sasha estimates the value of f to be 0.3. Calculate the percentage error in Sarah's estimate. Okay, so percentage error, right, is equal to the approximate value, right, minus the exact value divided by the exact value. Right, of course, the absolute value of this, we don't care whether it's positive or negative. All right, and then we multiply that by 100% to get a percentage. All right, so from here, all right, the approximated value is, I'm sorry, the approximated value is 0.03. So 0.03 minus our exact value, which is what we wrote up here. So 0.0375 all over 0.0375 times 100. You don't have to do the times 100 if you just know that that's going to give you a decimal, and we should be fairly proficient at going back and forth between decimals and percentages. All right, so here we can have, and I'm not going to worry about the absolute value. I'll just know that if it's negative, which it will be, that I just ignore the negative sign. All right, so 0.2, right, which is actually 20%. Yeah, I mean, the formula has the absolute value in there, right? So if you put the absolute value in there, it's just not going to do anything with that negative. If you actually use your absolute value, you don't need to worry about that at all. All right, so there's number one. Next, number two. Right, a rectangle is 3,260 centimeters long and 1,380 centimeters wide. Right, find the perimeter of the rectangle, giving your answer, and they call this standard form. Of course, we call it scientific notation. Right, so all we have to do is actually multiply this. So, of course, perimeter is 2 times the length plus 2 times the width. So I guess I'll go ahead and write that. All right, so perimeter is equal to 2L plus 2W. So in this case, that would be 2 times 3260 plus 2 times 1380. So we plug that into our calculator. All right, so that obviously is not in scientific notation, right? Of course, we could just know that that is 9.28 times 10 to the, 1, 2, 3 power. All right, you could also go to your mode in your calculator, go over to SCI. That'll put all of your answers in scientific notation. So when you do this again, 9.28 E3. You are not allowed to answer E3, right? If you write this exactly down, you will not get credit for it. They don't take calculator notation. But we do just need to know that that is 9.28 times 10 to the third power. Okay. Now, do be mindful that as soon as you're done, you'll want to go back to normal mode, right? You don't want all of your random answers being in scientific notation. All right, find the area of the rectangle, giving your answer correct to the nearest 1,000 square centimeters. So, of course, area is simply length times width. So in this case, 3260 times 1380. So 3260 times 1380. All right, this is 4498800. All right, so this is 4,498,800. It wants it rounded to the nearest 1,000. So if we round this to the nearest 1,000, that would be 4,498,800. 499,000. And that is it for number 2. All right, number 3. All right, consider the following 4 numbers. It gives us A, B, C, and D here. All right, one of these numbers is written in P times 10 to the K, where P is between 1 and 10, not including 10, and K is in the set of integers. Write down this number. All right. So the only one of these numbers that is in correct scientific notation, bless you, is B, 1.41 times 10 to the negative second power. All right, write down the smallest of these numbers. There's a couple of different ways that you can do this, right? You can basically just put them, whoops, don't want to do that. All right, you can basically just put them in your calculator one at a time so that you can get kind of like decimals, right? Now, of course, the first one you don't really have to. It's already in decimal form, right? 0.00141. But we'll do it nonetheless just so that it's in our memory here. I'm sorry, that's times 10 to the second power. All right, so that's 0.141. All right, the second one, we have 1.41 times 10 to the negative second power. All right, our third one is in, the form that we would like it. So 0.00141. All right, and then D, all right, we have the square root of 2 over 1,000. Okay, so these are our 4 numbers, and it says write down the smallest. So which one of these is the smallest, right? It's actually going to be C, right? Obviously, because it's 0.00, so is D also, right? But this one stops at 141.00141, whereas the square root of 2 over 1,000 has more, all right? So technically, C here would be the smallest. All right, so C, which is 0.00141. All right, write down the value of A plus B. All right, so A plus B, we simply say 0.00141 times 10 to the second plus B, which is 1.41 times 10 to the negative second. All right, 0.1551. All right, now, you probably should show your, like I would actually show this plus this just in case you make some silly mistake, just so you can get some partial credit. But for time purposes, I'll kind of try to get through as much as I can here. All right, give your answer to part C in scientific notation. Of course, this would just be 1.551 times 10 to the first power. Right, of course, you could do the same thing here, right? If we go into scientific mode in our calculator and then do the same thing here. All right. Oh, whoops, negative first. My mistake. Good thing I checked myself. All right, so, what's that? Because we're moving the decimal point, like to get from my scientific notation to my actual value, I'm moving it to the left, not to the right. Anytime you need to move your decimal point to the left, it's going to be a negative exponent. All right, we are done with 3. All right, number 4, the distance between 2 points with coordinates x1, y1, and x2, y2 is the following. Just for reference, that's also on your formula sheet, not under topic 1, but under like prior knowledge, like stuff that they just kind of expect you coming in to know. All right, but it is in there, even though they give it to you here anyway. All right, so calculate the distance between the points P20, negative 144, and Q2, negative 5. Give your answer correct to 5 significant figures. All right, so I'll kind of do this over here. So we're going to have the square root of x2 minus x1. So 2 minus 20 squared plus y2 minus y1. So negative 5 minus negative 144. And that's all squared as well. All right, so we plug that into a calculator. We get the square root of, and this would be negative 18 squared plus, and this would be what, 139 squared. Of course, you don't have to do it that way. And of course, I forgot to put it back in standard mode here. All right, so to 5 sig figs, it would be 140.16. All right, give your answer from part A correct to 1 decimal place. So that's just 140.2. So 1 decimal place here. All right, write down your answer to part B in the form basically scientific notation. All right, so this would be 1.402 times 10 to the second power. No, like from scientific notation, to get to this number, I have to move it to the right twice. Yes. Yeah. And you can always check yourself with a calculator, right? Like just put it in scientific mode and hit it in there. All right. So that one's relatively straightforward there. All right, number 5. In a recent mathematics assignment, Sophia approximated pi correct to 3 decimal places using the following expression. All right, A, calculate Sophia's approximation of pi correct to 3 decimal places. All right, so we come here to our handy dandy calculator. All right, we say 3 plus, get a fraction command, 1 over 5 plus another fraction, 9/5. All right, we hit enter there. All right, again, we don't want this, so you can just do 107 divided by 34. All right, 3.15 to 3 decimal places, 3.147. Say that again. Yeah, absolutely. All right, calculate the percentage error of Sophia's 3 decimal places approximation of pi compared to the exact value of pi using your calculator. So we're actually going to use the pi button. All right, so again, our error, we would have the absolute value of the approximate, so 3.147 minus pi over pi times 100%. All right, so if we put that in our calculator, so we have 3.147 minus pi, where's my pi there, over pi times 100. All right, so 0.172%. So she's really close. All right, so that's it for 5. Number 6. All right, the 15th term of an arithmetic sequence is 21, and the common difference is -4. Find the first term of the sequence. Okay, so we have our formula for the nth term, u sub n, and that's equal to u sub 1 plus n minus 1 times d. All right, so we know that the 15th term is 21, so u sub 15 is 21. We don't know u sub 1, that's what we're trying to find. All right, if we're talking about the 15th term here, my n is 15, and my d is -4. All right. Now you could go through and actually work this out, or what else could you do? What's that? Yeah, I mean, I would just use solver, right? So math, numeric solver. All right, so we can have 21. And my u1, of course, will just be x plus 15 minus 1. Of course, you could just make that 14 if you really wanted to, times -4. Alpha enter here to solve. All right, so u sub 1 is 77. Now, would you really need solver for an equation that simple? No, but could it save you some time? Sure. All right, B, find the 29th term of the sequence. All right, well, now we know that my formula for the nth term is 77 plus n minus 1 times -4. So if I'm trying to find the 29th term, u sub 29, that is 77 plus 29 minus 1 times -4. All right, so 77 plus 29 minus 1, of course you could just put 28 there, times -4, -35. All right, find the sum of the first 40 terms of the sequence. All right, of course, there's a couple of different ways to do this. You could use the S sub n formula in your packet, right? Or you could use sigma notation, right? So you could just say sigma from 1 to 40 of this thing up here, right? So 77 plus n minus 1 times negative 4. I mean, I guess technically you should probably bracket that so we know it's all included in there. All right, of course, like I said, you could just use the formula that's in your packet as well. All right, I'm kind of a fan of sigma notation myself. All right, so from here, we're going to go x equals 1 to 40 of 77 plus x minus 1 times negative 4. All right, and bada bang. All right, so negative 40.
How do you get the sigma thing?
You hit math, and you go up a few times until you see summation notation. There'll be a little picture of the sigma as well. So like here, if you hit math, go up a couple times. It says summation, but it also has that little sigma symbol, so you kind of know. Math up. Yep. All right, number 7. We already did this one, so apparently this is a repeat. Do I have it on there twice? Okay, sweet. Skip it. Saves us time. All right, 8. The third term, u sub 3, of an arithmetic sequence is 7. The common difference of the sequence d is 3. Find u sub 1, the first term of the sequence. All right, now, you could go ahead and use that formula like we did last time, like set up an nth term, but when it's really small and you're only trying, and they give you the third term, right? I've got blank, comma, 7. I know that my common difference is 3. That means I go up 3 every time to get my next term, which means this has to be 4 and that has to be 1, right? So it's perfectly acceptable to reason your way through it as well. So u sub 1 is equal to 1. Again, you could have used the formula for the nth term just like we did on the last problem, right? But that was like, gave us like the 27th term or something. So obviously we aren't going to try to reason our way through 27 terms. So that's why it was much easier to use the formula there. In this case, though, doesn't matter. All right, so now find u sub 60, the 60th term. All right, so we now know that u sub n is equal to u sub 1, which is 1, plus n minus 1 times d, which is 3. All right, so if we want to find u sub 60, that's just going to be 1 plus 60 minus 1 is 59, so that would just be 59 times 3. Of course, you would use a calculator for this, right? But that's 180, 177. I think it's 178. So, yeah. Okay. Then I won't bother. Okay. The first and fourth terms of this arithmetic sequence are the first 2 terms of a geometric sequence. Calculate the 6th term of the geometric sequence. All right. So here's the first term we know is 1. And then I have 4, 7. My fourth term would thus be 10. All right. So I know that my first term here is 1. My next term is 10. All right. Now, we could use a formula for this, but it's really easy. What is my r? What am I multiplying by each time? 10. So my next one would be 100, then 1,000, then 10,000, right? Then 100,000. And that is the 6th term. So u sub 6 would be 100,000. Now, could you just as easily use the formula? Absolutely, right? We know that u sub n is equal to u sub 1 times r to the n minus 1 power, right? So u sub 6 would equal 1 times 10 to the 6 minus 1 is the 5th power, which also would give you 100,000. So either way is totally acceptable. All right, number 9. A 3D printer builds a set of 49 Eiffel Tower replicas in different sizes. The height of the largest tower in this set is 64 centimeters. The heights of successive smaller towers are 95% of the preceding larger tower, as shown in the diagram below. All right, A, find the height of the smallest tower in this set. All right, now first, we're just going to come up with a formula, a geometric formula for the nth term. All right, so I have u sub n is equal to u sub 1 times r to the n minus 1 power. So in this case, my u sub 1 is 64. All right, my r is 0.95 to the n minus 1 power. All right, now part A says to find the smallest one, and we know that this is a set of 49. So I'm looking for the 49th, so u sub 49. All right, that would just be 64 times 0.95 to the n minus 1, so that would be 48th power. So we do that in a calculator here, 64 times 0.95 to the 48th power. All right, so to 3 sig figs, 5.46 centimeters. I think it was in centimeters. Yes. All right, find the total height if all 49 towers were placed one on top of another. All right, so that's, again, you can use your formula in your packet for S sub 49 of a geometric series, all right? Or you could use the sigma notation. All right, so we would go from 1 to 49, all right, of 64 times 0.95 to the n minus 1. So if we do that in our calculator, math up a couple of times to the summation notation, x is going from 1 to 49. Yes, sir.
I just found 49.
It actually says it in the problem. It says right up here that a 3D printer builds a set of 49 Eiffel Towers. So we know that there's going to be 49 of them total. All right, so plugging this into our calculator here, we have 64 times 0.95 to the n minus 1. Of course, 49 minus 1 is just 48. 267. Honestly, to 3 sig figs, you could just leave it that, 267 centimeters.
Wait, so you plug in 49?
From 1 to 49, because we're adding up all of every Eiffel Tower. We're adding up all 49 of them.
Well, then so why wouldn't you just leave it as x minus 1?
I mean, you could have just made that 49 minus 1. What's 49 minus 1? That's why I put 48 there. Doesn't matter, right? I mean, if you type it in like exactly as the formula gives it to you, that's totally fine.
You can't leave it. It's very important.
Oh my God, yeah, no, I totally messed up. There has to be an x variable. I'm a moron. Good call. All right, so what are we doing here? X minus 1, right? Yeah, it's going to be way bigger than this. It should be anyway. There we go. Whoa. So what was it? 11 something? 76. You could actually, I mean, you could write out that whole thing, or to 3 sig figs, it would be 1180. But you could, I mean, like, it's totally fine to answer 1176.32677, right? Like, they'll always take an exact, they consider that exact. So either way. Was that it for that one? Yep. Okay. All right, number 10. All right, the half-life, T in years, of a radioactive isotope can be modeled by the function T of K is equal to ln of 0.5 over ln of 1 minus K over 100, right, where K is between 0 and 100. And K is the decay rate in percent per year of the isotope. All right, the decay rate of hydrogen-3 is 5.5% per year. Find its half-life, right? So here, we just do T of 5.5. All right, so you just plug 5.5 into K here. So we will have ln of 0.5 over ln of 1 minus 5.5 over 100. Of course, you could have just put the 5.5 in as a decimal, same thing. All right, and bada bing. All right, so 12.2583496, of course, to 3 sig figs, we just say 12.3. All right, the half-life of uranium-232 is 68.9 years. A sampling containing 250 grams of uranium-232 is obtained and stored as a side product of a nuclear fuel cycle. All right, find the decay rate per year of uranium-232. All right, so now we know my half-life, right, is 68.9 years. So we're going to have 68.9, and that has to equal ln of 0.5 over ln of 1 minus K over 100. All right, what's the easiest way to solve this? Yeah, let the solver do it. Yeah. So math up to solver. All right. Next, I'll have on my left 68.9. All right. On my right, we will have ln of 0.5 over ln of 1 minus x over 100. Whoops, not 1,000, 100. All right, enter. And then, of course, alpha enter to solve. All right, so 1.0009, right? Technically, it would just be 1.00%, right? Yep. Okay. I'm going to cheat here. If any of you remember half-life formulas from either science class or pre-cal, right? It makes this go a lot faster, right? So our half-life formula, A is equal to P times 1/2 to the T, to the T over K power. No, this is not in the formula sheet. All right, makes it infinitely easier. T over K. Right? A is your final amount, P is your initial amount, T is your time in years, K is your half-life. Right? So here it says how much is left after. All right. So we're trying to find the final amount. It says that we start with 250 grams. All right, we have times 1/2. All right, to the T would be 68.9. This is silly. I didn't even really need to do this one. 68.9 is the half-life. How much should be left after when half of it's gone? What's that? 125 grams, right? That's half of 250, right? If 68.9 years is the half-life, right? It says it has a half-life of 68.9 years. That's how much, that's how long it takes for half of it to decay. So if we wait exactly one half-life, we should have exactly half of it left. No, K is the half-life, which they give us right here. The half-life of uranium-232 is 68.9 years. The time is like C1, 68.9 years. That's the time. C2, 100 years, right? So now we do the exact same thing, except now we plug in 100 for T instead of 68.9. Now, is 100 years more or less than the half-life? More. That means we should have less than half of it left, right? We've already gone past the point where we will get exactly half of it. So we just do 250 times 1/2. Whoops, don't want to be in solver. I raised to the 100 divided by 68.9 power. 91.4 grams to 3 sig figs. Okay. Number 11. Right, in this question, give all answers correct to 2 decimal places. So we do want to keep that in mind. All right, Mia deposits 4,000 Australian dollars into a bank account. The bank pays a nominal annual interest rate of 6% compounded semi-annually. A, find the amount of interest that Mia will earn over the next 2.5 years. All right, so here we're not doing any sort of like continuously investing, right? So we're not going to be using that TVM solver. She's just putting one amount in and letting it sit. So we're just going to use our standard compound interest formula. Of course, you can use the one that's in the formula packet. I don't have that one memorized. I have the one that we use in pre-cal memorized, which is the same, just different letters meaning different things. All right, so this is my A. All right, so my final amount will equal my principal amount of 4,000. All right, times 1 plus R is the interest rate. In this case, is a decimal. Remember, if you don't want to put it as a decimal, you can keep that 100 underneath the fraction. All right, N is the same as our K for our the formula that's in our packet. That's just how many times compounded per year. What does semi-annually mean? 2. And then we have that same 2 up here. All right, times T, the amount of time. In this case, it says 2.5 years. Now, we have to be careful here. When I plug this in, it's going to give me my final amount. Is that how much interest I've earned? No. How do I determine how much interest I've earned? Subtract 4,000, right? However much over my original amount, That's how much interest has been earned. All right, so here we have 4,000 times 1 plus 0.06 over 2 raised to the 2 times 2.5 power. All right, 4,637. Of course, if we subtract the 4,000, so 4637.0910. So 4637.10. So that's the total amount that she would have. All right, but the interest would just be $637.10. And that's Australian dollars. All right, Ella also deposits Australian dollars into her bank account. Her bank pays a nominal annual interest rate of 4% compounded monthly. In 2.5 years, the total in Ella's account will be 4,000 Australian dollars. Find the amount that Ella deposited in the bank. Okay, so we know that the final amount now is going to be 4,000. All right, we're looking for the original principal. All right, times 1 plus the interest rate is 0.04. If it's compounded monthly, this would be 12. Another 12 up here. All right, times the time, which again is 2.5. What's the easiest way to solve this? Yeah, you can use numeric solver. This one isn't too bad. You could just divide both sides by this whole mess, right? But you can absolutely use numeric solver. All right, so math up. Here we will just have 4,000. Here we will have x times 1 plus 0.04 over 12 raised to the 12 times 2.5 power. Enter. Alpha, enter. 3619.95. Good times. Okay. All right, next, number 12. Hannah buys a car for $24,900. The value of the car depreciates by 16% each year. A, find the value of the car after 10 years. All right, the easiest way to do this, all right, you could use essentially the compound interest formula where you have the 1 minus, right? Of course, you're only going to worry about compounding it once per year, and you would have a minus instead of a plus, right? But it's actually really easy. It ends up being the exact same thing as, all right, so if we're losing 16% each year, how much of the value are we retaining? Are we keeping? Somebody said it. 84%. Yeah. So we're going to put 0.84 in here because that's how much we're keeping. All right. And how long are we doing it? 10. So that's to the 10th power. All right. Now, that is the exact same thing. All right. If we did A is equal to P times 1 plus R over N to the NT. All right. So here my P would still be 24,900. All right, we would have 1 plus, well, technically this would be minus because we're depreciating. All right, and then we would have 16%, which is 0.16. All right, we're just doing it once per year. All right, so do we see how this is actually the exact same thing as this? Right? 0.16 divided by 1 is just 0.16, right? 1 minus 0.16 is 0.84, and then 1 times 10 is still just 10. All right, so whichever way you want to think about it, totally fine, right? I think of it this way up here. All right, so we just plug that into our calculator. So, whoops, don't want to be in solver. 24,900 times 0.84 to the 10th power. 4355.04. I didn't say to round it to 2 decimal places. They would accept that, or they would take 3 sig figs, right? If you put 4,360, they would take that. All right, Patrick buys a car for $12,000. The car depreciates by a fixed amount each year, and after 6 years, it is worth $6,200. Find the annual rate of depreciation of the car. Okay, so this is actually going to be more like a arithmetic sequence, right? Because we know that it just loses the same value every year. So I'm just going to have a negative d essentially, right? So we can still use that u sub n is equal to u sub 1 plus n minus 1 times d. All right. Now we know that each year and after 6 years, all right. So, I mean, I guess what we kind of need to talk about is, do we consider 12,000 to be u sub 1, right? Or not, right? Technically, 12,000 would be after 0 years, right? So, you know, we can't really count that as u sub 1. We'll just play around with it and see it. I'm going to call it u sub 0. Does that make sense? Like u sub 0 is 12,000 because when he bought it that year, that's how much it's worth, and it doesn't depreciate until the next year. Yes, no, maybe so. All right. So if we call this u sub 6, I'll just keep it u sub 1, and we'll after 6 years. This then would be u sub 7. Does that make sense? After year 1 would be u sub 2, right? After 2 years would be u sub 3, so on and so forth. So I know that u sub 7 is equal to 6,200, and that will equal 12,000 plus, we know that this is u sub 7, so this is 7 minus 1 times d. Right. Again, we can just use solver here. I mean, I know we're kind of abusing this thing, but it does save us a lot of time. Okay, so 966.67. All right. But I don't like this. They probably wanted that different. What's that again? I mean, no, it depends on how it's worded. When they ask for depreciation, giving a positive value is fine because it's understood that it's being taken away, right? But No, because it's a fixed amount, right? Compound interest, like the one up here, when we lose 84% when we lose 16% every year, like 16% of 24,900 is a different amount than 16% of whatever that new value is, which is a different, so like when you use compound interest, it's actually going to be a different amount that like, even though it depreciates by the same percentage, the actual overall amount that it depreciates each year is less. Okay. So when they want it to be like a fixed amount. Now, the reason I don't like this, right, is because I'm assuming that they wanted some nice whole number. So I'm going to assume that they just worded this problem terribly and that they actually wanted you to use u sub 6 for this. All right. So I'm going to just see how that affects my answer. So if that were 6, then n minus 1, 6 minus 1 would be 5. Yeah, negative 1160. I'm sure that's what they wanted. All right. So they just wrote this terribly incorrectly. I mean, I would give you credit for it. Hopefully, they wouldn't put one like this on the test where it was worded so poorly. Say that again. If not, and you missed a particular mark by a score, like by a point, I would argue to get it regraded. You know what I mean? And with like submitting my reasoning, like, oh no, you guys just worded that question totally terribly. Because if you're saying after 6 years, right, then this is how much it's losing each year, right? But I mean, unless that you're saying as soon as he bought this car, like as soon as he drove it off the lot, it depreciated 11 whatever it was, 1160. What's that? It kind of, yeah. I mean, I'm sure that they want it to be negative 1160. All right. I would totally accept either one of these, right? So if you assume that after 6 years is u sub 6, right, then that would be 1160. I would totally give you either. I mean, I would much prefer this answer because this is really what it means, right? Now, yes. And what's that? No, it's not. It says the car depreciates by a fixed amount. It doesn't depreciate by a fixed percentage. Because remember, like how we just said, if it's a fixed percentage, the actual amount that it depreciates changes every year, right? Where they said it's just a fixed amount. So it's not going to be a percentage. What's that? Yes, that's it. Now, again, 12,000, right? If you buy a new car, typically it loses some value as soon as you drive it off the lot, but not a used car. And I don't know too many new cars that you could buy for 12 grand, right? Like it's just not realistic, but whatever. I don't like that question, but either way, I would give you either. Like whether you just assumed, okay, they said after 6 years, so u sub 6, but technically after 6 years would be u sub 7 if you considered this u sub 1, right? Which you have to solve the, to actually put it into the formula. Okay, 13. Brothers Adam and Tim were each given $1,200 from their parents to invest to purchase their first car once they gain their driver's license. Adam invests his money into an account that pays an annual interest rate of 3.2%, compounded half yearly. Calculate the amount Adam will have in his account after 4 years, rounding your answer to the nearest dollar. Okay, so again, this is just investing one lump sum of money and waiting. So this is just going to be the compound interest formula. All right. So here we can say A is equal to P, which is 1,200, times 1 plus R, which is 0.032, over N, compounded half yearly, that's semi-annually, so that's 2 to the 2 times 4 power. And they do want the total amount in his account, not just the interest, so we do want that. So 1,200 times 1 plus 0.032 over 2 to the 2 times 4 power. Right, 1362.48. Oh, it wants to the nearest dollar. That's if they tell you specifically. It's if you're making like a payment regularly every so often, like every month, or if you're continuously investing, right? Like if you're adding to some retirement account or something every month, right? The only time you can use the compound interest formula is if you're just, I'm investing one lump sum and that's it. I'm just waiting for it to earn money. I'm never adding to it. So to the nearest dollar, this would be 1362. Tim aims to double his investment in a 4-year period. Assume that the account he invests in pays an annual interest rate of R% compounded quarterly. Determine the value of R Tim will require to achieve his aim. Round your answers correct to 2 decimal places. Now, do be mindful here that if you kind of use the formula that I do with like point, you put your interest rate as a decimal, right? That you're going to want to convert that to a percentage before you round it to 2 decimal places, right? So here we are he's trying to double his money. So 1,200 becomes 2,400. And that equals 1,200 times 1 plus R over compounded quarterly. So this is 4. You could also put that times 100 below here if you don't want to worry about that also. To the 4 times 4 power. All right, so again, I would probably use solver here to make our life easy. So 2,400 and 1,200 times 1 plus x over 4. Again, you could just make that 400 if you wanted it to be already in a nice percent. Okay, don't like that. That's annoying. Sometimes it does this if the estimation technique that it uses requires it to like change signs to go from positive to negative, and like that's kind of how it does it. Sometimes it'll just work because sometimes like the guess that it uses is automatically on the other side. So yeah, sometimes it'll work just fine. Sometimes if it doesn't, the way to fix it, what I kind of will do oftentimes is just make this 0 and then subtract it out here, right? Like if you just essentially set that equation equal to 0, right? You'd have to subtract 2,400 from both sides. So sometimes this will help kind of correct. Nope, didn't like it at all.
I used the regular form, like the comment from the packet, and that's sent to you.
Okay, cool. Yes, sir.
Why is it to the 4 times 4 power?
Because here it says that it's compounded quarterly. So that's the N or K, depending on which formula you're using, the number of times. And then it says after 4 years, after a 4-year period. I mean, I would just keep solving it until I had to, right? Like if you divide by 1,200 here, you're going to get 2 is equal to 1 plus R over 4 to the 16th power, right? Technically, this is pretty easy to solve without solver anyway. Then I would just take the 16th root of both sides, right? So then we would have the 16th root of 2 is equal to 1 plus r over 4. So then I would subtract 1 from both sides and then multiply by 4. All right, so to do like bigger roots like that, whatever root you want to do, hit the button, hit that number first. So since I want to do the 16th root, I'll hit 16, and then I'll hit math and come down here to this root with the little x as the index. And then when you do that, whatever number you just typed in there will become the index. All right. So 16th root of, what did I have here? 2. And that's all minus 1. And then I have to multiply all that by 4. All right. So 17.710%. To 2 decimal places. So 17.71%. Is that what you got? Yeah. And like, it's really weird. Sometimes like just the calculator you use won't like it, right? Now, oftentimes if you clear the memory, sometimes it will fix that problem, right? In fact, oftentimes it does, right? So if you come here and just say, all right, I'm going to clear the memory and now let's try this again. All right, so we had what, 2400 and 1200 times 1 plus r, of course, is what we're looking for, over n, which was 4, raised to the 4 times 4 power. We'll just see if that helped. Sometimes it does. Yep. Well, right. So cleared my memory and ran the solver again, and it worked just fine. So if you ever have a problem like that, and I mean, I've already seen multiple of you come to me like, what's going on, right? You just clear your memory. It usually works.
How do you clear it again?
You hit second plus because there's the MEM like down below the plus, which stands for memory, and then just 712. So you hit second memory. What can I what? What's that? During a test? I don't know. I mean, maybe like this first test, but the further we go, no. Because when you take papers 1 and 2 at the end of the year, they're not going to be able to tell you that. You know what I mean? First of all, the person proctoring the test probably wouldn't even know, right? But they wouldn't be allowed to even if they did. So, okay. So, good there. All right, number 14. All right, in this question, give all answers correct to the nearest whole number. All right, so we're doing whole numbers here. All right, Michelle takes out a loan of $12,000. The unpaid balance on the loan has an interest rate of 4.3% per year, compounded annually. The loan is to be repaid in payments of $1,500 made at the end of each year. Find the number of years it will take to repay the loan. All right, so she's making regular payments. All right, and it mentions end or beginning. So those are both big clues to using the TVM solver. All right, so we're going to want our TVM solver here. So we hit the apps button, which is right next to my math button. All right, finance application here. Very first thing is TVM solver. Again, that's the only thing that you're ever going to be like using from this. All right. Okay. Apps, enter. All right. Now it's asking us how many, like, find the number of years it will take to repay the loan. All right. She's only making one payment per year. So once we know the number of payments, that's also going to be our answer. Okay, so we don't know the number of payments. So we just leave it, whatever it is for the time being. All right, the interest rate here it gives us is 4.3%. All right. The present value, the value of the loan, is $12,000.
Wait, so what does N equal? Like,
We don't know yet. N is the total number of payments. That's what it stands for. All right, but you have to be careful there, right? Like in this case, it says she's only making one payment per year. So like the number of years and the number of payments will be the same, right? But like if they say she's paying monthly, right? Like then you're going to have to divide that answer by 12 to get the total number of years if they asked for number of years. All right, so do be very cognizant of what they're asking and kind of how everything's set up. All right. Her payments are going to be 1,500, technically negative 1,500, because remember, anytime something leaves your pocket, it's a negative number. Anytime something comes into your pocket, it's a positive number. That's why the present value was 12,000, because she got a loan. They literally gave her $12,000. All right. The future value, we definitely want to be 0. All right. Payments per year, 1. All right. Compounded annually. So the compounding periods per year is also 1. And it says that the payments will be made at the end of each year. So we leave that end. All right. So the only thing we don't know is N, the number of payments. So we move our cursor up to whatever it is we're trying to find. Right. And we hit alpha enter. Boom. All right. So 10.01, all right, it says correct to the nearest whole number, so that would just be 10. All right, now if you want any chance at partial credit, basically you want to like write this stuff down. This is what I plugged in for I. This is what I plugged in for PV, PMT, FV, right? All right, calculate the total amount that has been paid and amortizing the loan. All right, so, well, that's really easy. If we pay $1,500 a year for 10 years, 1,500 times 10 is 15,000. All right, so $15,000. B, the loan is to be amortized over 5 years. Find the annual payment made at the end of each year. Okay, so we go back here. We now know that it has to be paid in 5 years. All right, what we don't know is the new payment that she'll have to make at the end of each year. So we go down to payment and hit alpha enter there. Okay, so now her payment at the end of each year will be $2,718.
We still need it to the nearest one.
Yes. Right. It says in this question, give all answers. So that means everything involved with this question to a whole number. All right. And 2, calculate the total amount that has been paid and amortizing the loan. All right. So now she's making a payment of $2,718, but she's only making it for 5 years. All right. So $2,718 times 5. $13,590. Well, N stands for the total number of payments. In this case, she's only making one payment per year, so those are the same, right? But you're going to have to be very careful. If she's making monthly payments, no, N would be 12 times the number of years, right?
So it doesn't matter that we're using our rounded answers in
No.
first row.
All right. And this makes sense, of course, right? Like you always want to kind of think of things rationally, right? The quicker you pay back money, the less interest you pay, right? So that's why she only paid, $1,590 interest when she paid it off in 5 years, as opposed to $3,000 interest if she paid it off in 10. Does that make sense? Like, you have to pay more if you spread it out over a longer period of time. All right. And last but not least, let's try to get this last one in here. All right. A manufacturing company borrows money from a bank to purchase new machinery. The bank offers a 3-year loan at an interest rate of 13.3% per annum, compounded quarterly. The company accepts the loan and agrees to make monthly loan payments of $1,550 paid at the end of the month. All right. First, find the amount borrowed by the company. All right. So we're going back to our TVM solver. All right. Now, we're doing a 3-year loan. All right. And the company is making monthly payments. So if you make monthly payments for 3 years, how many total payments do you make? 12 times 3, which is 36. And you can type that in either way, right? You can just type in 36, or if you do 12 times 3 and hit enter, it will automatically do that for you. All right. What is the the percentage interest that they are getting? 13.3. All right. The present value of the loan, that's actually what we want to know, right? So we can't plug anything in there yet. All right. The company is making monthly payments of $1,550. Of course, that's negative $1,550 because that money is leaving the pocket. All right. Future value, we want to be 0. They're trying to pay off the entirety of the loan. All right. Payments per year. Well, if they're paying monthly, they're making 12 payments per year. And it says in the problem here that this is compounded quarterly. So this is one of the few times where the payments per year and compounding periods per year are different. And it does says that they are making these payments at the end of each month. So we do want the payments at the end. All right. So now we go back up to this present value, which is what we don't know, and we hit alpha enter. All right. So to the, I guess it doesn't say to the whole number here, does it? All right. So there's a couple of ways that you could answer this. They would take 3 sig figs, which would be 45,900. I'm sure that's what they're intending here. Again, if you want chance at partial credit, you need to kind of write down all of the things that you plugged into each part.
So we don't put the cent amount in the decimal.
Say that again.
So we don't put the decimal points.
Well, I mean, if you put the exact answer, they would take it. If you put 45,900.38293, they would take that. You're always allowed to answer exact as well if you don't want to do 3 sig figs. And whenever it's a calculator response, they accept everything that the calculator gives as an exact answer. All right, so find.
If it's money, do they always accept?
I'm not sure because a lot of times they tell you to round different things. I would assume. Okay, so find the total interest paid on the loan. Right. Well, they paid $1,550 every month for 3 years, so that's 36. Right. So we do 1,550 times 36. Whoops, not here. All right. So they repaid 55,800. So if you subtract the original loan amount, So that's not quite 10,000, $9,900. Yep. The company has some successful years and has accumulated $950,300 in their savings fund. The company wants to invest these funds to earn interest, and they find an annuity fund which returns 4.8% compounded monthly. The company wants the fund to last for 30 years while making regular, even monthly withdrawals to fund operations. C. Find the amount the company can afford to withdraw at the end of each month, rounded to the nearest dollar. Okay, so we have to start putting all this stuff in. Again, we want to go to our TVM solver. All right, they want this to last for 30 years, and they're taking out money every month. So 30 times 12 is 360. But you could just do 30 times 12 in there. All right, the interest rate that they are getting is 4.8%. All right, the present value, the money that they have in there, is 950,300. Although technically, I think we have to make this negative.
I'll leave it for now. It's so hot and sweating. I want
Okay.
you to try it.
Okay.
This is celery.
Okay. What is it? Just a hot sauce or?
Mango habanero.
Oh, okay.
But you gotta try it.
I will.
Let me know.
Where'd you get it from?
Not doing a book.
Okay.
But it's so hot.
All right. So the payment we don't know, right? We don't know how much they're going to be withdrawing. Future value, we do want 0. Payments per year, we do want 12 because they're taking it out. All right. And it's compounded monthly as well. So the compound periods per year would also be 12, and they are taking out at the end. All right, so we want to see what our payments are here. So we solve here. $4,986 rounded to the nearest whole number. So $4,986. After 15 years, the company needs to increase the monthly withdrawal due to rising operational costs. They determine they now need to withdraw $6,500 from the fund per month. All right, so this is when stuff starts to get tricky. All right, find the amount of savings in the fund when they made the decision. Round to the nearest dollar. Okay, so first we go back to our TVM solver. All right, and I'm just going to make this 49.86 since that's what we're kind of rounded it to. All right, but now, all right, after 5 years, wait, is that what they said? After 15 years. So basically halfway through, right? So halfway through this 360, they didn't make it through all 360, right? They only did 180. 15 times 12. All right, so now we want to know what the new present value is. Okay, so alpha enter. Oh, no, wait. Sorry, we want to know what the final value is. I'm an idiot. All right, so they are still going to have $638,850 in there. 638,850. Okay, find the number of years after they make this change that the fund runs out of money. Okay, so now we have to change a lot of stuff up in here. All right, so now the present value is going to be this 638, 850. All right, the payment, the money that they're taking out now becomes 6,500. All right, the future value again is going to be 0. All this stuff down below that stays the same, payments per year, compounding periods per year, and they're taking it at the end. So we want to know how many months will that last. All right, so 125 months essentially. All right, so divide that by 12. Whoops, son of a biscuit. Well, it is 10.4, but all right, so 10.4 years.